Today is from case by case to scalable solution, typology approaches in historical building renovation. This is the agenda, so we will have a brief introduction, and then we will start with highlighting the challenges and potential solutions for future-proofing heritage buildings for the energy transition. Then we'll get to the core part of the presentation, that is the typology approach that the two projects are developing. And then to the third part, so an overview of the innovative solution for the energy renovation of heritage buildings. And then we will have time for Q&A and discussion. This is our speakers today. So I will be your moderator. And then for the first part, on behalf of the FuturHist project, we will have Jan Grangirard, the head of climate change at the Edinburgh World Heritage. Then for the second part, the main part, talking about the typology approaches will be Alessia Buda from the HeriTACE project, architect and postdoctoral researcher at the Politecnico di Milano, Elena Poma from the FuturHist project, postdoctoral researcher at Eurac Research. And then for the third part, we will have the coordinators of our two projects. So Ellen Imf for HeriTACE, research manager at Ghent University, and Daniel Herrera from FuturHist for the Eurac Research. Just to introduce you, we will use the Slido for interaction between us and the public. You can join from this QR code or at slido.com with this reference number. And I will show you this QR code again, so you will have the chance to join also later on. And now I would like to start with a couple of questions to get to know our public. So, which country are you joining us from today? A lot of people from Belgium. Good. Okay, all over Europe. That's nice. UK. Oh, Portugal, Norway. Nice. Oh, Malaysia, India. Very nice. And then another question, just to let us know what are you doing and how your profession is also related to this webinar. Architects, researchers, students, great. Very nice. Okay, so it's a mixed audience. I think it's very nice. So we can go on. We can start with the first part and the first speaker.
Thank you, Marta. So good morning, everyone. So I'm going to talk about the challenges and the potential solutions in relation to the energy retrofit of historic buildings. All right. I've got some issues to move the slides. All right, there we go. Thank you. So historic buildings are pretty diverse, and you have a couple of examples here from Edinburgh, and they have different degrees of protections. Sometimes they don't have any protection at all, but they still have a cultural value, and it's very important to protect it. For the HeriTACE and FuturHist projects, we consider historic buildings to be built before 1945. And they are very important in the transition to net zero or for a clean energy transition. Just in Europe, there is 1/4 of the existing building stock that was built before 1945. And in the UK, around 20% of the housing stock was built before 1919. Energy retrofit covers both repairs and improvement to existing buildings, and there are many benefits in doing these projects, mainly to reduce carbon emissions and energy consumptions, but also to improve comfort and indoor air quality, to name but a few aspects. There are many requirements in relation to these projects, and there is a need to mitigate multiple risks. And there are also many stakeholders involved, but that would depend on the size of the project and the type of client. So if we move on to the next slide. Right, I'm going to give you an overview of the challenges. And we'll move on to the next slide. So one of the first challenges, the lack of understanding of the heritage significance of historic buildings. And you have some examples here on this slide where the cultural significance is pretty obvious for these buildings. So they are less at risk of inappropriate intervention. But if you look at the next slide, and for more common buildings, like for example, domestic buildings, they are more at risk in terms of inappropriate interventions. You can see on the left-hand side, out of 8 flats, there is only one that retained the original design for its windows. So in terms of pattern and material, all the rest have inappropriate patterns or even sometimes UPVC windows, and we are in a conservation area. Windows are a really important feature for historic buildings. The example in the middle is a window that has more than 100 years and retains some of original glazing. So it's very important to preserve them. Moving on to the next slide. So there is also a strong misunderstanding about how these historic buildings have been designed, how they're meant to perform, and the technical compatibility with the original and the materials that were used to build them. Often the mistake is to try to apply modern construction techniques and materials to historic buildings, and that could lead to unintended consequences. For instance, the use of cement pointing, and you've got an example in the middle that can accelerate stone decay. But also the use of impermeable materials and combined with a lack of ventilation could lead to mold growth. And that's what you can see on the left-hand side. In the construction sector, we also lack data on historic buildings, whether it's about the categorization or the quantification of historic buildings, but also in relation to the energy performance before and after any retrofit project. There are other aspects, such as the embodied and operational carbon, also waste management. Although there are a few databases that are available on the web, it's sometimes difficult to find them, and they can be discontinued, as it happened for the Retrofit Scotland website. There is also a lack of holistic approach when retrofitting historic building, in particular in domestic buildings. People tend to approach their retrofit project just considering their own flat in isolation and not considering the whole building. And there are opportunities for improvements to the shared parts of these buildings. So, for example, the roof, but also the common stairs. And there are opportunities to implement and install shared renewable energy systems or shared heating systems as well. In relation to the retrofit projects, in general, there are many criteria to consider, from the protection of the cultural value, but also the user's needs and aspirations, the smart readiness of the building, and also aspects such as low maintenance costs, to name but a few. Maintenance is too often overlooked, yet that's the first step for energy efficiency, but also climate change adaptation, to make sure the building is more resilient to a future climate that is going to be more adverse. And it's a critical aspect to make sure we are future-proofing the retrofit interventions. But the problem is costs are often omitted in relation to maintenance in retrofit projects. In the FuturHist project, we ran a survey to ask about the main barriers to energy retrofit in historic buildings. And what we found was that barriers are often interconnected and not easily categorized. There are some overlaps. The importance of these barriers varies according to the local context. But what was clear is that regulatory and financial barriers dominate for the sample of respondents we had in our survey. Now I'm going to give you an overview of the challenges from the perspective of different stakeholders in retrofit projects, starting with building owners and tenements. And the main questions for them are, where should we start? What can we do? And who can we ask to do this retrofit project? So it's a problem about guidance that is often too complex or too general, but also a general lack of impartial advice, especially for historic buildings. They're also experiencing challenges in relation to the planning process to get approval from local authorities on the works they are proposing to their buildings. If we look at, if we look at designers and practitioners, so by this we mean architects or engineers, they really need tools to support the design process. So to gain time, to facilitate the comparison between the retrofit scenarios they can design, but also to ensure the reliability of the results, and more generally to maximize the outcomes of their design. So it's really a matter of creating new tools when there are gaps, especially in terms of heritage value and impact assessment, mainstreaming these tools, but also simplifying some specific tools or creating specific guidance in relation to economic viability and environmental aspects. And if we consider policymakers, they're under huge pressure to deliver net zero to facilitate that transition, but there are tensions with heritage regulations. So there is a need for a balanced approach, and they have to enable the adoption of new technologies to facilitate the transition, but at the same time, that should be done in line with the best practice for historic buildings and decades of knowledge in that relation. Finally, if we look at the contractors, there is often a lack of understanding in terms of the heritage building significance, the way they were designed and the way they are meant to perform. They're often very specialized on one single aspect of retrofits, for instance, insulation, heating systems, or windows, which could lead to a piecemeal approach and unintended consequences, as we've seen already. They are also in a fast-changing landscape in terms of standards, in terms of technology, and that requires training, but they often don't have necessarily the time to train, so which could pose problems further down the line. So now we're going to look at the solutions we need, and starting with the need to help people to easily understand cultural significance and make sure that they integrate heritage at the very start of the process. So we need a specific approach, but also tools to help with that. And you can see on the slide, for example, drawings that would identify what's important in terms of heritage significance for the building, which means we can define where we've got opportunities for change without undermining the cultural significance of the building. We need globally to speed things up by introducing and mainstreaming a typology-based approach for energy retrofit, by grouping buildings and defining replicable packages of solutions that would help identify and protect common element of cultural significance, and also help address common issues and risks. So doing so in a way that requires minimal adaptation when we're considering specific buildings within the typology. So it's a matter of avoiding the reinvention of the wheel all the time, but just giving the information and a roadmap for each typology to everyone. We also need to provide replicable technical solutions for individual building elements by mapping the solutions and defining whether they are applicable for each typology. Keeping in mind that whilst we do have different typologies, there are still common building elements between different typologies. And you can see on the right-hand side some examples from Dublin, Amsterdam, and Edinburgh in terms of sash and case windows, historic doors, but also walls made of brick. in the case of Dublin and Amsterdam. So we need to promote and enable project stakeholders to adopt a holistic approach, to develop by developing, a retrofit approach process, decision-making support tools and guidance to raise awareness of the risks and help mitigate them, to help stakeholders to make the right decision and consider all the retrofit aspects of the project. So to embrace the holistic approach and to showcase best practice via case studies and guidance to help people know what can be done. So that's the end of my presentation, and I'll hand over back to Marta.
Yes, so after the presentation, if you want to share what you think is the main challenge, we are glad to hear what you think about it. So financial seems. Skills and knowledge gap, yeah. So yeah, lack of knowledge and financial costs seems to be the greatest challenge, in your opinion. Bureaucracy as well. Building standards. Thank you. Okay, I think we can continue, and I will leave the floor to Eline for a brief presentation of the projects.
So also the previous slide. Can you go one slide back? Thank you. So also the European Commission recognized the challenges that Ian just explained, and in context of its Green Deal and European Bauhaus launched a call for proposals called Future-Proofing Historical Buildings for the Clean Energy Transition a few years ago, which is actually providing the context for the two projects we are discussing today, that are the two projects selected within this call, being the FuturHist and HeriTACE project. The question was to target building types with cultural heritage value, meaning that they would have renovation restrictions, and especially also targeting building types that are representative of a significant part of the country's building stock. The aim is to develop standardized renovation approaches and solutions that are directly replicable for buildings of the same typology. The EU also set the ambitious goal to target energy demand reductions of at least 60% while preserving the heritage value, but also considering a wider range of criteria, including indoor environmental quality, cost effectiveness, use of renewable energy sources, smart readiness, maintenance costs, and construction waste. Next slide. So as a very short introduction, the HeriTACE project aims to navigate this delicate balance between energy use and heritage value by proposing a holistic and multi-scale renovation approach. Holistic meaning that we look at a wider range of performance indicators and we integrate those at different levels. So we look at solutions of building elements and how they can be optimally integrated within the building and the different parts of the building, but also look at what solutions the neighborhood can give for the building and how buildings within their neighborhood can be more optimally foreseen from renewable energy sources. We look at this integration both at the level of the building design and the actual building operation and control. The Renovation approach is supported by development of some specific innovations of dedicated elements for the building envelope, HVAC and energy solutions, of which you will learn more later on in this presentation. And the HeriTACE project chose to work on a typology of townhouses within historical neighborhoods, historical cities, which will also be introduced later today.
Thank you. Good morning, everyone. I'm Daniel Herrera, and as coordinator of FuturHist, now it's my turn to briefly introduce what the project is about. As Salim introduced already, we are both answering the same topic call of the European Commission, so there's a lot of things in common. Can you go back one slide, please, Jan? Yeah. So there's a lot of things in common. There's also some differences that I want to highlight as well. So whereas in FuturHist, we're trying to focus on more than one typology and looking at different typologies, not with the ambition of covering all the typologies, but rather trying to learn how we can replicate the results from one to other and trying to escalate the results a bit faster. The idea is that we are developing a streamlined, a standardized approach, as the European Commission was asking us for, and looking always at a typology. So what is that we can do, what level of definition we can reach when we're talking about a typology and not at a single building. And then what typology means to us, you will learn more about it in the next presentations. So with this standardized approach, we would solve hopefully part of the problem, but not all of it. There's also the demonstration and development of passive and active solutions that are compatible with the energy retrofit of historic buildings. And we are tackling this in both ways. On the one hand, developing new solutions, but also demonstrating that the solutions that exist are compatible and how they can be more easily identified for the right application. And lastly, as I said at the beginning, we want to enable scalable replication so that what we do for one typology can be transferred to other typologies. That this is something we're also tackling within the project on transferring the results from one to another and seeing how we can do that to accelerate the interventions.
Thank you, Daniel, and thank you, Eileen. We can continue to the next part of the presentation then.
Hi, good morning. I'm Elena Poma, and in this second part of the webinar, I'm going to present you the application of the typology-based approach in the FuturHist project and how we have defined certain typologies for certain historic building that we are addressing in the FuturHist project. Sorry. Yeah. Of course, we all know that every historic building is different. However, we can't avoid noticing that there are similarities between historic buildings, especially when we look around in European cities. And in some cases, the distinction between one building and the other is not even so clear because they are made of the same materials, they share similar layouts, and sometimes they're even attached one to another. And these similarities not only occurs in city, but they also occurs in more rural areas. And that is why, and that is because building typologies and similarities between buildings depends especially on climate and availability of material at the time in which they were constructed and designed. And that is because they were pre-industrial design and production. So acknowledging that there are clear similarities between many historic buildings in Europe, the FuturHist project was developed to test the potential application of replicable solutions, which are based on a typology-based approach. When we look at the built heritage in cities, we can try to get a broader perspective. And by doing this, it is possible to group the buildings together because they share some similarities. And these are, for example, construction features, but they can also be geometrical ones, use ones, and they're also related to the time of their construction. And once we group them, we can try to work at a different scale to design solutions to make them more efficient. by focusing, instead of the difference between one building and the other, focusing on what these buildings can have in common. And these are elements that can be replicated and refurbished in a similar way. And by doing this, we hope to speed up the renovation rate of built environment. So currently, when an historic building has to be retrofitted or refurbished to become more energy efficient, the process is most commonly adopted is the case-specific one. So starting from a real historic building, there is a complex process of designing of the retrofitting project, and the result of this is a set of tailored solutions which have been designed specifically for the single case. And this is a very effective way of designing a solutions for historic buildings, because it takes into account the complexity of the challenge, but it is also a very time-consuming effort, because it involves many professionals and many dimensions of designs. So what we see also from the European perspective is that we need to speed up this process. And to do that, with the FuturHist project, we asked ourselves if it is possible to change this workflow. And instead of starting from the historic building itself, what if we could start from a set of tailored retrofit solutions which are compatible with these types of building, and then develop a retrofitting project based on a starting point. So to start designing on something that is already there. What is the link between tailored retrofit solutions and real buildings? The link we have identified is the building typology. And this is how we define it in this project. So for us, a typology is a set of buildings which have common properties. And these properties can be related to the time of construction, the geometry, but also the use of the building. But more about this in the second part of my presentation. So if we go one step back to what is a case-specific approach for designing a retrofit process for an historic building. As you see here, many professionals are usually involved in this process, and they come from different backgrounds, and they are used to work with different targets. And besides that, there is also the fact that retrofitting an historic building, which has a heritage value, it's a challenge that involves different dimensions, some of which are not even measurable fields. And for example, the conception of heritage value, the perception of heritage value, and also the involvement of people who inhabit and use these buildings every day. So our idea is not to avoid this, because this is something that we have to do if we want to preserve the value of our buildings. But our idea is to put the typology at the beginning of this process. So trying to address these professionals and multidimensional aspects of the project. And do that from the typology point of view. And instead of obtaining, as a result, a set of solutions that is only applicable to a single building, we aimed at coming up with a set of solutions which are tailored for the typology. And this means that this set of solutions act as a sort of filter between the thousands of solutions that we can have for any building in the world. And they provide a short list of solutions which are directly applicable to any building that belongs to a typology related to this. Sorry. I don't know if I can still move it. Okay. So just to provide you with an overview of the process, what you see in orange is the typology solution design. So as you see, the people involved and the dimensions involved are the same, but the effort is much reduced in the project phase. So when working on real project, if we use as a starting point the outcomes of a typology-based approach. And this process is meant not to change the way historic buildings are treated because of their value, but just to make the process faster and more efficient. Here you see a more clear overview of what is the boundary between typology and real buildings in application and also in the FuturHist project. So the level of this workflow are different ones. So at the top you see how typology tailored retrofit solution stands between the typology and the real historic building. And at the bottom you see how the evaluation process is carried out in different steps. So we have a typology-based evaluation phase, which is preliminary to any real project. And then when we move forward to renovating a real historic building, we start from a set of compatible solutions, which have already been provided for this type of building. And we can proceed with building-based evaluation. So a different scale of details for the evaluation and different types of tools. And with that, we can, in the end, select the solutions which are really feasible and are compatible not only with the typology, but also with the real building itself. And this is something that we are also doing in the FuturHist project as a demonstration with real buildings that, as this one, that belongs to a typology and for which we are developing and also testing the typology-based solutions. Okay, now before we move to the second part, there is a Slido question for you. So the idea is to understand if from the audience you already addressed typologies in your work. Yeah, I see yes. That's good. Or if you use them, if you use typology-based approach. I noticed many designers were in the audience. Marta, when you think it's good moment, we can also move to the open question.
Yes, you can move to the open question maybe, as a lot of yes have been answered.
Okay, so if you have a bit more time, you can tell us in which context you've come across typologies, because that's a very broad field. Okay. Research. Practice, design, energy retrofit, guidelines development. Okay, I see also a lot of construction-based typology. Okay, thank you for the answers. So maybe we can keep collecting answers in the background. Is that fine? And we can get back to the discussion, but that's very useful for me to go on. Okay, so now that you know how we want to use typologies in our research project, I would like to tell you a bit more on how we have defined them. Because as many of you work with typologies already, you all know that there are many definitions of a building typology. And it's also not easy to define what are the boundaries of it. And there are several approaches. So in the FuturHist project, we started from 5 real buildings, which are also our demonstrator buildings, in which we will test the solutions. And starting from these real buildings, we wanted to identify, first of all, the typologies to which these buildings belongs. And how did we do this step? So this is a simplified version of the workflow we followed. So in the first step, we just collected building properties that were already used in other previous research in literature or even in European data sets about the building stock. Because we did not want to invent anything here. We just wanted to come out with all the possible properties that we can use to define a building, because we were starting from the bottom, so from real buildings and not from typologies themselves. So after this collection phase, we actually collected data about the buildings we have analyzed. So starting from the list we made in the first step, we collected a lot of information about these buildings and information that deals with their context, with their history, with their materiality, with their use, with their location. And after that, we made a distinction between all the inputs that we collected to differentiate properties which define the building themselves, so constant ones that are present in all the building that belongs to the same typology, and variable ones, so properties that can vary between buildings of the same typology. And this distinction is very important because, as we said, every historic building is different. So the typology does not represent all the buildings of the same type, but is a sort of abstract, simplified version of real buildings that have all the main defining features constant. And just to give you an overview, these are the features that we have selected in FuturHist. So we have on the left the one that define the typology, and these are related to the original state of the buildings because they have to be constant over time. So they relate to how the building was designed and realized in its original configuration. So of course the age, time, and context are very important. Sorry, I think it's moving by itself. And then we have, of course, geometrical parameters, which are very important when you want to look into energy performance. And these can be also range-based. This is an important aspect of typologies because as we are dealing with historic buildings where nothing is really constant from one building to another, they are not mass-produced factory products. There are, of course, ranges to include and to characterize geometrical parameters as well as construction ones. And then we have also features that are related to the architectural style, which for some typology is defining features, the layout, of course, the original use, and heritage attributes. So as defining features, we decided to refer to specifically elements that have to be preserved because they are iconic of these buildings and they are present in all the buildings that belong to these typologies. On the right side in green, you can see instead what we have defined as variable features. And these, as I anticipated, deals more with the situation of these buildings today. So variable features means that we have a most representative scenario for these properties, but these properties do not define the typology itself because we can have two buildings that belong to the same typology, but one is still used as a housing as it was designed to, but the other one instead is a office, for example. And the same applies to the spatial situation because, of course, surroundings change over time. So the buildings do not find themselves always in the same situation. And this also applies to the heritage value. Because not all buildings that belong to the same typology are protected at the same level, or they have been preserved over time in the same quantity. And also they are not perceived in the same way if they are not used by the same user or located in the same location. And here you can see the 9 typologies we are working on with the FuturHist project. So 5 of them that you see closer to the map are also related to the real demonstrator buildings. And for each country, we have also defined an additional typology based on buildings that are commonly found in these areas. And we will use this typology also to develop further typology-specific solution sets. And I would like to conclude by telling you that for each of these building typologies, which of course are country-specific, but some of them are also present in similar ways in other European countries. And for each of them, we have produced identity cards, which contains the most important information about the typology and that allow people to recognize them and understand if a building that they have seen might belong to this typology. Of course, not all the features are there. I'm afraid it is cropped. At least I see it cropped. I don't know if that's the same for you. Sorry about that. So just I just wanted to show you what are the most important features with a practical example. So, of course, the construction material are the most important aspects to define a typology when we want to use it for energy retrofit purpose. So to understand the materiality. And based on these, we can quantify in terms of ranges the energy performance of envelope elements and of the overall building. And then, of course, we have information about the climate, the distribution of these typologies. So how many buildings belong to it in a city or in a region, and what are the iconic heritage features that have to be preserved. Okay, thank you. And I give the word to Alessia.
Thank you, Elena. Yes, so now we will continue with the perspective from the HeriTACE project.
Yeah. This is control. Okay, perfect. So, stop. Okay. Good morning to everyone. I'm Alessia Buda. I'm from Politecnico di Milano, and I will present you the typology approach and the heritage value assessment method we have developed within the HeriTACE project. As Eileen presented, the HeriTACE ambition is to work on strategies for selected townhouse typologies using an archetype approach to define an holistic assessment model for this type of buildings at neighborhood scale also. So according to the meaning of archetypes as typical and repeated principle of building design with some clear characteristics, we have worked on 4 countries in 4 cities, which are also UNESCO protected, defining archetypes through an analysis that involved the use of literature, heritage experts, and also the knowledge coming from past projects. And so we have selected 24 case studies that are single or multi-family dwellings predating 1945. The scope was to understanding how to achieve the goal of climate neutrality in these typologies Also, according to the fact that in the recent years, a push on the topic has been given by the publication of the guidelines, the N 16883. We know, as you have also confirmed in the slide or before, that this process is really time consuming, needs a lot of knowledge, and is not that easy for professionals, but also for heritage boards to be passed through in a building. So the scope of HeriTACE was to understand for similar buildings, as we have also seen in the FuturHist project, if we can repeat we can avoid to repeat the entire process every time, so to speed up the process and set some holistic targets. According to this scope, we have worked on two sides. On one side, we have worked to simplify the process through the definition of a multidimensional model, archetype scale. On the other side, we have worked to define some tools that can support in reality the process suggested by the standard. In particular, what we will see is the process we have developed for implementing the historic buildings knowledge analysis. So, as you also have underlined in the slide, we have difficulties in collecting data, in understanding the heritage significance of building. So we have started our analysis starting from archetypes and case study selection to define technical documents, methods to facilitate the systematic collection and storage of data in the context, of course, of energy retrofit interventions. These parts is thought to be functional to the definition then of baseline scenarios to be implementing the multidimensional model. So in the idea of supporting the investigation both at single building and neighborhood level, we have defined this method to make the understanding of multiple values in the buildings and the neighborhoods easier. The starting point to define this method was to work in reality on case studies, also discussing through users' needs survey. The creation of the technical sheet was developed in two parts. The first part, as you will see, is the building identity card. The second part is that to have an assessment of a broad range of heritage values. The document we have developed has two main characteristics. It's thought to be simple and shareable, with criteria that are objective and flexible to be used also in other contexts, respect to those of heritage project. So, as I said, the first part is the building identity card. I will just go through the elements we have defined to analyze in the building the main characteristics such as building geometry, geographic context, ownership, architectural characteristics, also including pictures and technical descriptions. Then we have huge part dedicated to building elements. So for each of the building elements, we have we have some lines dedicated to the definition of element typologies, state of conservation, and also the recognition of valuable elements that is important at the end of the process for implementing the building value assessment. This part is also including a technical installation section, and then the summary of building and technical installations, state of conservation, is important to resume the need for intervention. That is fundamental for then implementing retrofit solutions. The building value assessment sections is thought to be used in both cases if the buildings are listed or not. In the first case, is possible to use these parts to recognize additional presence of values, consulting also the conservation authority. The second case is thought to recognize the presence of values, new values. So is a process which require detailed knowledge of the building transformation from the past to the present. Each part is supported by examples and questions, so it's simple to be used also by architects which has no knowledge about value recognition in detail or conservation experts. However, it's for sure suggested to be supported all the time from heritage authorities or other professionals. In this case, as you can see, we have recognized historical, cultural, architectural values that are the most common values we recognize in a building, but we have also included aesthetic values and scientific values linked to the presence, for example, in this case, of passive ventilation systems through a wind tower that was not more in use in this typology of traditional man-to-man building. The building value assessment is also including an authenticity and integrity parts. These two to indicate the preservation of building peculiarities, not necessarily in a perfect conservation state, but important element that should be considered when retrofitting the building to avoid incompatible alteration of the construction. So from this detailed analysis of all case studies, we have run this process, this method in all 24 case studies. We have discussed about how to develop replicable strategies for archetypes. So 2 steps of generalization were developed with the conservation experts involved in the project. We have agreed, firstly, on common heritage value categories that apply at building components level. At second generalization step with the expert was to develop baseline heritage value scenarios at building level, in which each time the categories we have defined of valuable measure are specified at building components, of course, based on the expert knowledge. These heritage value scenarios represent typical situations that serve as basis for developing then the baseline scenarios for each archetype that includes also the heritage value scenario, but not only that, as you can see in the slide. So the heritage value categories we have defined are 5, starting from conservation, measures allowed to any measures allowed, which of course is possible to be used in cases where the heritage value is not present. In our townhouse case studies, we are mainly focused on the steps which come from the first to the third, so from low to high impact measures. As I said, is the situation of heritage building as a starting point. It is important to use these value categories as a reference for assessing then the performance indicator. Some examples of the solutions we can find in our deliverable about baseline definition. So we have solutions for each of the building components at envelope level, of course, which range from, for example, in the windows, from installing joints to reduce air leaks, to moving to the substitution of existing glass as medium impact solution, then to the change of windows, which is considered if some parts are already damaged or affected by decay in an high impact part. So the use of these heritage impact scenarios was important to then define our heritage value scenarios. For each archetype, as I said, we have considered possible solutions. We run from the really high protected building, which is the value scenario 0, to the not protected building, which in this case, in this archetype, is the value scenario number 4. In heritage project, we mainly, as I said, focus in the middle. So based on these scenarios, we have defined 2 typologies of renovation baseline scenarios: pre-renovation baseline, so before the energy renovation. This was defined considering the situation of the building as in the period of the 90s, in which the building was gone through all renovation measures, so no EPD were implemented. EPD inspired renovation measures were implemented. And then we have defined the renovation baseline scenario, so common practice renovation, actually, common practice renovation. All this process will be important for us to then define new solutions and new strategies within the HeriTACE process in the creation of a multidimensional model. So now we can go to the Slido questions. Marta.
Oh. Yes, you can still change if you want.
Yeah. Okay. So, would this approach be useful to your profession? I've seen a lot of designers. It would be interesting if someone wants to test this method. If you would like to test it, we can also be contact the project.
Well, it is a full yes with this question.
Okay, let's go to the second question.
Yeah.
I don't know why I can't move. Okay. Are you familiar with the EU standards, in particular with the EN 16883? No. also in this case, it would be nice to have a discussion about the challenges in applying these standards. More no, that's yes, it's interesting. Okay. Thank you. I think I can give the word to the next presenter, Eline.
Good morning, everyone. Again, from my side, I think I will start with this part of the presentation, and then I'll hand over to Eline. So the idea for this last part of the presentation was to give you an insight, a bit of a peek view on the other things we are working in these two projects, HeriTACE and FuturHist. On the one hand, to make you aware of what we are doing, and hopefully also to attract your interest. So we will plan not more webinars or more information and disseminate more results so that you are aware of what is coming up and hopefully to get your interest. Rather than doing two separate presentations, we have worked together, Eline and I, in preparing these slides and summarize all these different solutions we are developing. For you to keep track of things, we have also come up with this idea of these colored bullet dots that you will see next to different solutions presented. I will help you identify which of the projects is working on that and to what extent. So if you see a dark colored ball next to an item, it means that that project is working intensively on that. If it's just empty, it means that it's not something that is being addressed by that project. And the intermediate is something that is dealt with, but not in full extent or not as much as the other project maybe. So with that, I'll try to move. Yes. So starting from the idea of developing a simplified or standardized approach, as the European Commission was requesting us, we're both projects working on this and working a multidimensional methodology that is something that takes into account all the dimensions and all the problems, as we all have identified today, also the participants of the webinar that are involved in the retrofit of a historic building. Maybe in particular about what we are doing in FuturHist is trying to develop this toolkit, this integrated planning toolkit that supports along the process. And that has started already since the beginning of the project, where we have identified a series of indicators, key performance indicators and decision criteria, that are, we think, important in the decision-making process. So we've started from defining what are the aspects that we want to consider, and the idea is to develop that into something that is simplified and that is adapted to the typologies. Starting with the typologies that we are working with in the project, and with the hope, with the view long-term that this will be extended to other typologies. What is important to highlight or to remark again is that both projects are working at this multi-dimension methodology. So we want to not only look at energy reduction, we also want to look at aspects of technical compatibility, heritage conservation, and so on. I mentioned or something that has been mentioned in the previous presentations is this long list and short list. So we start from the idea that retrofitting of historic building is not only a technical problem or technological problem, it's also, there is a number of solutions that are available and that are potentially compatible with historic buildings. Sometimes the access to this information, the awareness of this existence of this information, it is a problem, it is a limitation. So what we are trying to do in both projects is to identify a long list of solutions. So what are all the potential solutions for the retrofit of a historic building that exist, and trying to define this short list of solutions that are those solutions that are potentially compatible with a certain building typology. So excluding those that are for sure not compatible and leaving those that might be compatible. And then in the later stages of the design process, refine them even further. This is something that both projects have done. You see just here, for example, just for reference, an example of a documentation sheet from the HeriTACE project and another one from the FuturHist project, with similar information maybe communicated in slightly different ways. Then moving on to the development of new solutions and focusing on the passive solutions. First, so on the building envelope, we are dealing with new solutions for interior insulation, so improving the thermal performance of the opaque part of the wall by insulating it internally, with solutions that look at improving the insulation of historical wooden facades, mostly in changing northern climates. Also the development of new prefabricated lime-based insulating panels that facilitate the use of lime with an offsite construction, so reducing waste and facilitating the implementation process. And lastly, exploring the use of biochar as a construction material that is natural, therefore ecological in terms of embodied energy and compatible with the heritage of a building, and develop it into an insulating and moisture regulating materials or products for the renovation. Moving on to the exterior insulation, we are also working on systems for the thermal insulation of the envelope from the outside. And this is whether it is a comparison of different approaches or the development of new plasters that take some of these materials that I presented before. We are in any case developing and testing all of these solutions. In addition to that, we are developing a external render for the protection of the facade that will enhance the potentiality or the autogenous properties of lime in self-healing over time. So that is improving the durability of the external render and ensuring that there is no water ingress that will lead to a damage or decay of the facade. And lastly, exploring the possibility of using portable NMRs, or nuclear magnetic resonance, as a tool for non-destructive on-site testing of the moisture absorption properties of facades. So in order to be able to insulate a wall internally, we need to make sure that externally that facade is not absorbing water that would lead to moisture accumulation and then decay of the facade. And we are exploring this as a non-intrusive or non-destructive method. We are also looking at windows as an important element of the building, whether in terms of energy performance, but also of heritage significance and character of the building. We are looking at tightness and energy performance, and we are looking both at developing new solutions, but also measuring the improvement or the impact of these solutions on the performance of the window, whether it is on-site and whether it is experimental testing or calculation of both air tightness and energy performance. In terms of typologies of windows, just to mention some examples, we're looking at double or box type windows. Depending where you come from, you might call it slightly different, but also as sash encased windows from the demonstration cases in the UK, and wooden balcony doors. So also improving the thermal performance of the opaque part of the window. And also an interesting aspect is how we can improve the summer comfort conditions in northern countries, where the shading elements might not have been as explored as in other latitudes, and how we can make this as an improvement of comfort and energy performance in other latitudes. I think now I can hand over to Elin.
Yes, thank you, Daniel. I will continue with some of the more active solutions that are developed in both projects, starting with some solutions regarding the ventilation of providing indoor air quality in the buildings. I think in both projects, there's of course a lot of focus on how to integrate ventilation concepts, existing ventilation concepts within heritage buildings, looking at the properties of the building and their heritage value. How can we integrate such solutions? Secondly, there is work on performance-based ventilation concepts that allow to provide indoor air quality exactly where and when it is needed, so to avoid that there are heat losses due to ventilation in rooms where there is no ventilation need at that moment. So it's related to the design and control of such ventilation, and we specifically look at how this can work for the buildings we are looking at, taking into account they often have also a lower air tightness and so on. Regarding that, performance-based should not only look at indoor air quality, but should look at indoor air quality, but also at risks related to moisture in the building. So one of the solutions both projects are also looking into is the combination of insulation strategies that could increase moisture risks in and on building components, and how to avoid these by using ventilation solutions. So it's searching for a balance between the insulation of the building, the providing air tightness to the building, and also the ventilation concepts and how they can optimally work together for optimizing also the energy efficiency of the overall result. Continuing with heating and cooling solutions, there is the development of a tool which allows to assess for designers in an early design stage what the potential is for ventilative cooling of their building as a more natural way of cooling, providing cooling within the building, within different climate zones. Then, of course, regarding the emission, mostly the emission part of the heating systems, we look at how existing systems can be transformed to low temperature heating, which allows them to connect to more sustainable heat sources, but also how to, how existing emission elements within the buildings, which may also have a heritage value, can be reused, can be integrated in more hybrid systems, or can be complemented with other solutions so that we can still use them, but also go towards more sustainable heating sources. Then, of course, also the design and control of the systems is important when we're going to insulate the buildings, when we are going to provide other sources for the heat. We need to look at how the emission systems are designed, whether they still fit the purpose, and to control them in a way that comfort is provided exactly in the rooms and the places where they are needed, and also at the moments that they are needed, in order to avoid needless energy losses. So this is strongly in relation to occupant behavior as well. Regarding then the providing of energy and storage of energy, both projects are also looking at how renewable energy systems can be integrated in heritage buildings. This is often a challenge because of the heritage restrictions. So, for example, how heat pumps can be integrated in or on or in the surroundings of historic buildings. What is possible with regards to photovoltaics and building integrated photovoltaics. Also in HeriTACE project, new BIPV modules are developed that integrate more aesthetically within the roofs of historic buildings. Also, as mentioned before, there is the level of the energy providing energy at the level of the building, but we can also look whether energy sources in the neighborhood can be exploited in order to make our heritage buildings more sustainable. Therefore, there is research on some of the more unharvested heat sources within historic cities, such as the potential of reusing heat that is stored in large attics of, for example, churches or bigger buildings, of underground parking garages that we often find also in and around historical centers, and also the use of thermal storage to that regard. On the district heating level, there's of course then the importance of how the buildings and the energy sources can be optimally integrated into district heating grids that operate at lower temperatures, so the 5th generation district heating as that is called, where we look at how to optimally design regarding the different buildings and their needs, regarding the different heat sources, but also to control that in an optimal way so that during the operation you can maximize the use of renewable energy sources and provide so you can maximize and you can match demand and supply in the most optimal way. There's two levels of so building integration or integration of solutions in the building is a very crucial thing within both projects. And Daniel will first explain about how it's done via demonstrations.
Yes, thanks, Eileen. The idea was to add a word here to highlight the importance of the role that demonstrators are playing in the FuturHist project. Although we are working at a project that is a research and innovation action, so that is still like an early in the technology readiness level of the solutions, we have decided to go all the way to a demonstration in a real building. On the one hand, we wanted to really tailor every solutions we develop within the project to actual typologies, so to be concrete in what we develop as a product or as a solution, and to have them implemented in and validated in the demonstrators. The idea is that then this demonstrator will help us engage with the relevant stakeholders, with these heritage authorities, owners, and decision makers, and eventually to use this as a starting point for replication. So if we have developed a solution that we agree with together with the stakeholders, it works for a certain typology, what is needed, or whether it will work for another typologies in the same context or in a different context. So whether it is depending on the physical properties of the building or on the more climatological or even heritage aspects of the context where the building is located. Back to you, Lynn.
Yeah. Okay. So another way of looking at the integration of solutions in the building is via a lot of simulation work that's done in broad projects. We're talking about simulation of energy, comfort, indoor air quality, so typically with building energy simulations, but also simulation of heat and moisture transport to investigate moisture risks in building components and those effects. Within the project, those technologies or techniques are used to investigate and develop some of the solutions that we have mentioned before, and also to assess the performance of those solutions when they are installed or integrated within a case study building or an archetype building of the project. As we know, building simulations can provide a lot of knowledge and insight also in the design phase of a project to better understand what could be the optimal solution for the renovation of the building. However, they require quite some expert knowledge and or also could be time-consuming tasks. Therefore, both projects are thinking of ways how this task can be somehow avoided or simplified for the users who could finally use the results of the project. Where the FuturHist project is exploring the idea of providing more simplified simulation methods and to check there whether the simplification of the methods still allows enough accuracy, and is it still usable enough to see whether these solutions can be provided for designers. On the other hand, the HeriTACE project and possibly also FuturHist in a later stage could focuses on actually providing detailed simulations by experts during the project. We do them for a variety of scenarios of renovation solutions for the different archetypes we provide in order to provide results to the users later on via a sort of database and tool, so that people can actually look up the results for a building that is quite close to the building they have without the need for them to do the simulations by themselves. So we'll hear later how both approaches turn out. The final goal, we talked a lot about optimization before. What we are looking for is, if we look at the level of the entire building, how we can optimally integrate and combine a number of solutions for the insulation of the building envelope, and also solutions regarding HVAC for the different heritage building typologies that both projects are working on, and accounting not only for heritage value and energy performance, but also for a much wider range of performance criteria. Within the project, there is also attention to this at the level of the design, but also at the level of the control so at the moment that the building is operational, how these concepts optimally work together and how they should be controlled, accounting for the dynamics of the building, how they are used, when they are used, and also the dynamics of renewable energy supply that is not always constantly available, but so the interaction can be optimized. Some examples or some specific examples from the project is, for example, the search for passive solutions providing summer comfort and moisture regulation within the FuturHist project, or the combination of optimizing insulation and ventilation solutions to reduce both moisture risks and increase energy efficiency within the HeriTACE project. Specifically for the HeriTACE project, there is a scale up towards the neighborhood level, as I introduced before. And so also there, the optimization of integration of the different buildings, each having their own energy demand profiles, the renewable and residual energy sources that are available within historical neighborhoods, how to optimize that at the moment due to the design, but also by controlling the system is also a solution being investigated. This brings me to the end of a very short overview of all various aspects that are further investigated in both projects. And so I hope this could raise your interest for maybe future webinars. I think there's another Slido question. With the question to you, which of the topics mentioned before would be of specific interest for you if we would organize future webinars together from the projects?
I don't know, Marta, if it's possible that we start answering some of the questions while people take this poll, because we have run a little bit long, not too long, and I saw there were some questions I would, if possible, take the chance to.
Yes.
So we could start with the questions in Zoom, but I see there's also some questions via the Slido in the meantime. So normally, if you have questions, please prefer to put them via the Zoom question and answer.
Mm-hmm. Yes. So we have a few questions on Zoom. As you say, we can start from that. Well, a question is that we haven't mentioned Southern countries typology, and if we know which are the typologies in these countries. I know we have Italy in our case, but here they say we don't have any typologies, for example, from Greece or Portugal.
Yeah, it's true. I mean, I can say we have 2 typologies in Spain as a southern country, but it's true that there isn't any in Greece and Portugal as in many other countries of Europe. And that's why I think both projects eventually would like to continue working on that to extend the number of typologies, but definitely in FuturHist is the goal that towards the end of the project, we explore the replicability and we have some activities planned and especially designed to that on what is needed to adapt the approach we have developed for these typologies we have within the project to other typologies, how much additional effort is needed. And we will be doing that in the last part of the project. So yeah, I can only invite you to follow along. We would also do a summer school next year where we will start dealing with that. So if you're interested in working with typologies that have not been mentioned, please follow along or even contact us directly, and we will for sure keep you involved and then offer you for some other opportunities to engage.
Thank you, Daniel. And another question is, what about long-time monitoring of the retrofitted buildings?
Well, for HeriTACE, I will not answer that in the sense that, as I explained before, the project is at a rather low TRL level, and so we are not having a lot of actual demonstrations within the case study buildings. We merely use our case study buildings to learn about the existing situation and very well understand how the buildings are constructed, what are their properties, what is their heritage value, and so on, in order to make sure our archetypes are as good as possible. However, there is very limited to the application of renovation measures in the demos is in the case studies is not a big part of the HeriTACE project. So also long-term monitoring is not part here. So maybe for FuturHist, Daniel could explain.
Yes, we are definitely monitoring already the buildings we will be working with before any intervention. And that yes, well, after the project, as far as possible, we keep the monitoring going. Depending on the interventions we plan on the different demo cases, we have different monitoring foreseen. But yeah, that's something we can present at another webinar if there's interest in that.
Thank you, both of you. We have a couple of other questions that maybe we can address from Slido.
Yeah.
So one question is, how do you think, or how do you think you would develop measures for historic buildings with single elderly occupants and limited heated rooms. How would you include usage patterns in typologies? Celine?
I'll maybe start. So within the HeriTACE project, we look at it at 2 levels. I think for a general performance assessment to compare a number of solutions, we consider a kind of fixed use scenario, which is normally complementary with the expected use of this kind of building. So as if they are fully in the use they were designed for or capable of. However, we realize and we know that in many cases in these heritage and historic buildings, they are underused. This is a thing that we really see quite a lot. So within the HeriTACE project, we look at different user profiles when we investigate the optimal solutions. So we will be looking at a number of typical other use profiles for the building. Also, we consider the aspect of energy sufficiency, the fact that people, especially in older, less insulated buildings, accommodates to the fact that they cannot have 22 degrees in all the rooms all the day long, which has become more normal in new, very energy efficient housing. So this is a way of saving costs, but also a kind of sufficient behavior that comes with the use of the building. So that is an aspect that we are also investigating when we are looking at the insulation of the building, but also looking at the HVAC solutions for the building. So within the project, that sort of topics would definitely be addressed.
Thank you, Aline.
Maybe Daniel also wants to add for FuturHist, because I'm not sure.
No, I think that to some extent applies to both, and there's some more questions, so I think we can maybe move on to the question.
Yes, we have one last question we can address is what material are you using for insulation in your attics?
Okay, I think maybe this we need to answer both. From our side, from FuturHist, we are developing and testing one external insulation system, and that is made of mostly biochar and lime as a binder. Biochar being the waste from biomass sources used in pyrolysis. So that is the leftover from this energy process and has stored all the carbon within, and it becomes a very porous and fibrous material. So it has potentially very good thermal and hygroscopic properties.
Within the HeriTACE project, at this point, different sorts of materials are investigated, such as EPS, phenolic foam, wood fiber boards, and mineral wool. So the combination of the plasters and the insulation materials is investigated to see how the thermal and humidity moisture performance is.
Thank you. Thank you, both of you. Just to answer a bit more logistic questions, the presentation will be available after the webinar. Also, the recording of the webinar will be available, and we will share the contacts for both projects if you have other questions that you want to address to our speakers or in general to the project coordinators. So I think we can conclude here. As we said, this was the first webinar organized from the 2 projects, and the idea is to launch a series of webinars for collaboration to explore both the challenges and the solutions that we are facing. And so I hope you will follow us in this route with the other webinars. And huge thank you to our speakers.